So here's a couple of videos from one of our Addison homes that we're wrapping up. This house uses ductless mini splits on the lower level and a ducted system on the upper level. The ductless systems don't have very high latent removal capacity. So we have a dedicated latent removal system, otherwise known as a dehumidifier. This is a whole house dehumidifier, similar to the one we played around with in class, a lot bigger, and it actually does two things. So it's got return air coming in from the house, going through the dehumidification coil, and then supply air going back to the rest of the house. But it also has a motorized damper that allows fresh air in from outside. So we're bringing fresh air in. This is also our ventilation system for the house. We're bringing fresh air in. We're taking it through the dehumidifier. We're mixing it with the return air from the house, dehumidifying it, and then supplying fresh air and dehumidified air back to the house. And we want to protect the coil, but we also want to filter that fresh air and the whole house air. So this becomes our filtration system. You can see this is about a 2-inch thick media filter. And lo and behold, it is a MERV 13. It's not 2 inches thick, it's 1 3/4 inches thick. It's a MERV 13 filter. So in this particular house, we have a MERV 13 that's filtering the fresh air and the dehumidified air, and then that's for the whole house. We also have a ducted system upstairs that has a MERV 16 filter on it, and I'm gonna take some video of that too. Another thing I want to point out in here though is we have a heat pump water heater. So this is a water heater that uses the vapor compression cycle up top and heats the water by circulating that refrigerant through the coil. So we're removing heat from the ambient air and we're putting that heat into the water. Super, super efficient way to heat water. And then the other thing we're doing, because this is vapor compression cycle, when we remove heat from the air, we're also removing some of the latent energy from the air. So we're moving some of the moisture, and the moisture is draining out and going to the condensate drain. But this dehumidified and slightly cooled air is then going and getting fed to the rest of the house. So part of our strategy on this particular house is from an energy efficiency standpoint and a controlling sensible standpoint. So the energy guide on this one, this is an 80-gallon heat pump water heater. It's only going to cost about $160 a year to operate. As comparison, a all-electric water heater would cost about $400 or $500, if not $600 a year to operate. Okay, we're gonna head up to the mechanical room up in the attic. We actually have a conditioned space in our attic up here. So we have a conditioned room built inside the attic to keep all of our ductwork inside conditioned space. So here's our air handler and the ductwork. And the ductwork in this particular house goes down through some interior walls into the floor system between the first and second floor. So I wanted to do this video to show you the air filtration on this ducted system. This happens to be a Mitsubishi ducted system. Got the two lines, refrigerant lines coming in, liquid line and the vapor line. Got the condensate drain, draining out, everything's insulated. And then here's our central filter. This is the filter for the whole upstairs of this system. We have ductless downstairs and ducted upstairs. And then here we go. So there's our 5-inch thick MERV 16 filter. And just to give you an idea of what that looks like, darn air handler is running, but this is what Lennox calls their MERV 16 carbon clean. So you can see the deep pleats, and it's impregnated with carbon. So it also does some odor removal. This is about a once a year filter change out. Get another view on the other side. And this filter is jam up. So there's our strategy.